Hello, you all. Okay, I said today we are going to keep going with your notes on proportions. So look where you have proportions and similar figures, okay, in your table of contents. We're going to keep extending that idea in your notebook right now. So with this first problemo, what we're going to try and figure out, well, I'm going to tell you, or I'm going to ask you, is rectangle LMNO, is rectangle LMNO similar to, so instead of writing out similar to, I'm just going to use the symbol similar to HIJK, rectangle HIJK. And remember in your notes, similar figures, similar polygons have to have one, first thing they have to have are congruent angles. The corresponding angles need to be congruent. So I look at, this statement is super important. I'd look at, is L, that's supposed to correspond with H, are L and H congruent to each other? Check, yes. Are M and I congruent to each other? Check, yes. All right, you can see that J and N and K and O are congruent to one another. So we are good there. This is check, we're good. Okay, second thing that has to happen are the sides, the corresponding sides, that's super important, have to be proportional to each other. So I would check and see if they are. And again, I'm going to use this statement to find the corresponding sides. I don't just look at it and say, oh, I think these are corresponding. So LM, side LM, is supposed to be corresponding with HI. LM and HI. So I'm going to form a ratio 10 to 8. And I'm going to see, is that ratio the same with all the other sides? So let's go to MN with IJ. MN, so I'll do a different color. MN with IJ, 4 to 3. And is that the same ratio equivalent to NO and JK? Again, a different color. NO, JK, 10 to 8. Which also needs to be the same as the last set, L with O and H with K. And that was 4 to 3. So are these the same? Well, it looks like we have the same set here than there. So I can just check the cross products and see if they're equal. I have, oh man, 8 times 4 is 32. Is that the same as the other cross product of 30? No! This did not work out. They are not in proportion to one another. So, after all my work there, I would say and write out that rectangle LMNO is not similar to rectangle HIJK. These are not similar. And why is it? It's not because of this, it's because of this. The corresponding sides are not proportional. They're not in proportion to one another. Okay, let's look at another example. Okay, let's say you are designing a poster. Ooh, good for you, Miss Designer, Mr. Designer. You're sketching a sketch for the letter H. So you're making an H. And this is the sketch of the letter H and how you want it to look. The letter will be 9 inches tall on the poster. If the two letters are similar, what is the width on the poster? So we're going to say that this number we want to be 9 inches, and we want to know what then will be the width. Well, if the two letters are similar, then their sides should be in proportion. So I'm going to say, well, this 5 would be relating to the 9, just as the 4 should be relating to our unknown, our width. So I'll use a W there. So that would tell me my sides are in proportion. And now we have a simple proportion to solve, and we could use a ratio table, or we could use the cross products. I'm going to go ahead and use the cross products. 9 times 4 is 36, and that's supposed to be the same as 5 times W. So to get W, I'm going to divide by 5, and I am not going to get, a whole number here, but 36 divided by 5 goes into 36, let's see, 7 times, and I'm left with 1. So from right there, I could write it as a mixed number, 7 1/5 inches, or I could plug in a decimal, and x is 0, and 5 goes into 10 twice. So I could say 7 1/5 inch or 7.2 inches for the width. If I want to keep that letter H in proportion and not have it be distorted. Okay, one more. Ooh, look at that pretty picture. That's beautiful math right there. In this figure, triangle ABC is similar to triangle DEC. I am telling you that is given. It is true, whether you like it or not. So if they are similar, you are told they are similar, I want you to find the value of x. Now the hard part in this problem is that the two triangles are overlapping. So what I would do first is split them up. I'm going to draw a triangle ABC, ABC, and I'm going to write what I know. I know AB is 18. I know B to C is, 8 plus 16, which is 24. And I don't know AC, so I'll leave that blank. And now I'm going to redraw DEC. And DEC, what do I know there? Well, I know DE is X, I know EC is 16, and that's all I know. So now maybe you have an idea of what to do. To get X, well, if these are similar, I know their sides are in proportion. So the corresponding sides, AB corresponds with DE. AB corresponds with DE. So I'm going to say 18 goes with X, just as BC goes with EC, BC goes with EC, 24 goes with 16. Sorry, I keep coughing. And from there, I have my proportion, which I can solve however I want to. And you know what I'm going to do? You probably know cross products. But I would actually make this a little simpler. I'm going to go 18 over x, and I'm actually going to simplify this first and use some smaller numbers. So if I simplify that, I could divide them both by 8, and I'll be at 3 over 2. So that'll just make my proportion multiplying easier. You don't have to do that. And then from there, if I double 18, I'll be at 36. And then 3 times x, divide by 3, and my x value, my unknown, would be 12 feet. Cha-ching. Okay, so this would be 12. Now that was my final example, but I want to extend the idea once more. If I keep this picture, and now I say, okay, you think you're really good? Well then, if DC is 14, what is the length of AC? So if we erase what we did there, and now I tell you if DC is 14 feet, what is the length from A to C? So you go ahead, try and figure that out, and you will submit your answer on the quiz. Okay? See you later, people.